Part 2, Ice Age Theory.
Thinking outside the box. I've just given you the thoughts and concepts by Muller and MacDonald in 1995. Now I'm going to present a radical change in thinking about how the Earth rotates. The Earth actually has two axes of rotation, the solar axis and the orbital axis. But during Ice Age interglacial periods, there is little rotation on the orbital axis. How do we know this? It has been assumed that the present is key to the past and that the precession cycle of 25,766 years was the same during the last Ice Age as it is today. Controlling angular momentum. Controlling angular velocity on a rotating stool, as in this video clip. The man, when he holds weights in his hand out from his body, his rate of rotation slows down. When he brings those weights close to his body, his rotation speeds up. Since the changes in Earth's spin on its orbital axis are very slow, it takes as much as 7,000 years for rotation to decrease at the end of an Ice Age period. Does that mean that when the Earth's orbit is aligned and within the accretion zone of the Sun, that the mass of the Sun is added onto the Earth as if larger weights were added onto the chair spinner's arms in the video? If that is the case, then the angular momentum of the Earth would be dramatically decreased during an interglacial period when the Earth is aligned with the Sun's accretion zone. I was looking for what would happen when the Earth's orbit is no longer in alignment with the accretion zone as it is today. Would that mean that the Earth would have freedom to rotate on its orbital axis when its orbit is mostly outside of the accretion zone due to the Sun's wobble on its own axis? When the Earth's orbit is not aligned with the accretion zone, can rotation on the Earth's orbital axis change or increase? How can Earth's rotation on its orbital axis accelerate? My theory predicts that the eccentric distribution of mass inside Earth would be pulled by the Sun, thereby causing the southern hemisphere to track the Sun with the South Pole pointing inside Earth's orbit. That is, based on the orientation of the solar axis, which is tilted by 23 degrees from the Earth's vertical orbital axis. In other words, the Earth rotates on its orbital axis much faster during an Ice Age. The Earth would then rotate on its orbital axis one complete turn every year, like the Moon rotates on its orbital axis around the Earth. To recap, my theory predicts the Earth rotates differently between Ice Ages and interglacials due to the wobbling of the Sun on its own axis, which is why we have Ice Ages alternating with interglacial warm periods. This is very different from what we find in the geologic record. This relationship was very different before the Pleistocene period, when at least 6 climate cycles of different duration were nested within the next larger cycles. We know this because of coring in rocks 190 to 230 million years ago. Olson et al., 1995. We know that a major change in celestial mechanics occurred at the beginning of the Pleistocene because of ice coring in Antarctica and in the Arctic Greenland that go back 800,000 years from the present. Berger et al., 2015. Another problem is the amount of ice that accumulated in Antarctica during an Ice Age. We know that the northern ice cap grew extensively all the way down into North America, but radar data showing the landforms below Antarctic ice provide evidence of V-shaped valleys, which are typical of tropical climates. And ancient sea maps, as presented by Hancock in 1995, show a progressive icing of Antarctica at the end of the last Ice Age, not the reverse. In Graham Hancock's 1995 book, Fingerprints of the Gods, he presents in his first chapter, Introduction, the mystery of the maps. These are maps from the 16th century which show how the last ice age ended and how Antarctica, which had been free of ice, became covered with ice, and an ice shelf developed around that island continent. He says, "The combined effect of the Piri-Reis, Orontius Phineus, Mercator, and Bausch maps is the strong, though disturbing, impression that Antarctica may have been continuously surveyed over a period of several thousand years as the ice cap gradually spread outwards from the interior, increasing its grip with every passing millennium, but not engulfing all of the coasts of the southern continent until around 4000 BC. The original sources for the Piri-Reis and the Mercator maps must therefore have been prepared towards the end of this period, when only the coasts of Antarctica were free of ice. The source of the Orontius Phineus map, on the other hand, seems to have been considerably earlier, when the ice cap was present only in the deep interior of the continents, and the source for the Bausch map appears to originate in even earlier period, around 13,000 BC, when there may have been no ice in Antarctica at all." This contrast between a massive ice cap in the northern hemisphere and hardly any ice cap at the southern hemisphere is consistent with the tilting of the solar axis, with the South Pole pointing inside the Earth's orbit and the North Pole pointing outside the Earth's orbit during an ice age. That would mean that the southern hemisphere was bathed in sun as the Earth rotated on its orbital axis 360 degrees each year, and the sun rarely would set in Antarctica, while at the North Pole, the sun would rarely rise above the horizon during an entire year, and the North Pole would be much colder than the South Pole because it tilted outside the Earth's orbit during each ice age. According to my theory, the current distribution of the continents and oceanic crust favors the South Pole pointing towards the sun because the solar axis is at a 25.5 degree angle. The Earth rotates simultaneously on two separate axes during an ice age, that is the solar axis and the orbital axis. Only when the Earth's orbit is completely in line with the sun's ecliptic or accretionary disk is the rotation on its orbital axis braked or stopped, like a spinning skater holding his arms out. That alignment occurs in a rhythm of a 1/5 beat over a 259,200 year cycle, caused by the sun's axial wobble. That is 21,600 years for the interglacial, 108,000 years for the Illinoisan Ice Age, 21,000 years for the Sangamonian or Eemian interglacial, and 108,000 years for the Wisconsin Ice Age, followed by the Holocene interglacial, in which we are located in time. This chronology is based on ice cores from the Arctic, Greenland, and the Antarctic. To proceed with this video, go to Part 3.